Welcome. So we are doing a sequential logic circuit design exercise. It could be a tutorial or even exam question. So let's see what is uh, given here. Draw the truth table and the excitation table for SR flip-flop. Copy the excitation table and answer the subsequent questions. So let's start with completing uh, our SR flip-flops truth tables. Okay. So in SR flip-flop we have S, R, two inputs, right? Then we have current state which is QT, and the next state is QT plus 1. Okay. So these are the combinations we can consider as inputs, but yeah, this is the internal state, right? These two are the external inputs. But let's fill up the table for all the configurations which we can have. 0 1 0 0 0 1 1 0 0 1 1 0 0 0 0 1 1 1 1. Okay, so these are the all the configurations of this SR flip flop can have. So our task is in our truth table is to determine what is the next state going to be based on the current state and current inputs. Okay, so how is the SR flip flop behaves in each of these configurations? Okay, so if S and R are both 0, essentially it does not change the current state. So current state is 0, so it will preserve that state to the next layer. Okay, so here S and R are 0, but current state is 1. Since these two are zeros, it will preserve the current state to the next state as well. Okay, so if S is 0, R is 1, what is going to happen? Current is 0, so R is essentially reset, right? It's going to set the uh, flip-flop's value to 0. Okay, uh, even though the current state is 1, if the R signal is set and S signal is 0, then we are going to reset it. Okay, so this also will be 0. If the set signal is set and R is 0, that means we are going to set the value to 1 despite what is the current state. Okay, so S and R both are 1 and the current state is 0. So this is actually a race condition, right? We have to avoid this situation uh, at any cost in our SR flip-flop circuits. Okay, so this is going to be a racing condition. I will just put a star here saying that okay, this we must avoid, right? So now what is the excitation table? So this is the truth table, right? Current, based on the current state, we are determining what is our next state. Now what is the excitation table? We have a Q, right? Qt current state, and we need some Qt plus 1 of our own desire, right? We want this transition to happen, and we need to determine what are the S and R signals which can satisfy our requirement, right? So Qt and Qt plus 1 could be in different uh, orders, right? So if Q is 0 and we need 0 in the next state as well, what is the SR configuration we need? If Q is 0 and we need 1 here, what is the transition? If Q is 1 and we need Qt plus 1 to be T plus 1, right? Okay, to be 0, then what is the transition, right? If Qt is 1, Qt plus is also 1, what is the SR signals we need to set? So this is the thing we are trying to determine using our excitation table. Okay, this part is excitation table. So you can take a look at this truth table in order to derive a proper signal or proper configuration for our requirement. Okay, so if we are going from 0 to 0, right, we can look at this table and figure out where we have that, right? First row or 0th row, and this row also has 0 to 0 transition, right, or 0 to 0 change. Okay, so there are two states or two configurations we can achieve that, right? So we have this one, right, which is changing from 0 to 0. This also change from 0 to 0, right? So by looking at both of these conditions, what we can say is, if the S is 0, so we have S is let's say 0, R does not matter. Okay, by doing this, I mean, if S is 0, R does not matter, we will go from 0 to 0. Okay, if Q is 0 and we need Qt plus 1 to be 1, so where do we have that? Here we have a 1, right? There is nowhere else, right? So we need to use this configuration. There is no option. So S must be 1 and R must be 0 in order to go from 0 to 1. Okay, 1 to 0, 1 to 0, we have this one, right? So this one is going from 1 to 0. We need 0, 1 in this configuration. Okay, so then going from 1 to 1, what can we do? There are two options here, right? One is here. This one we can use, sorry, or this one we can use, correct? So here, what is the thing which does not say, does not change? R must be 0, right? S does not matter, but R must be 0. This does not matter. Okay, so this is our excitation table for SR flip-flop. So next we will see how we can use this to design a circuit.